Hello! I think we... Right? Yep. Alright, we do have audio. We gaming. So, how is everyone? Tonight... the best emotion. Incredible, isn't it? So, tonight, we're going to start by looking at what we've got so far, which is pathfinding. Pathfinding is working now. So I can add walls, and the penguins will have to path around them. You can see already kind of some of these penguins out here. They're like going all the way around. So it might be tough to see. Can I have like full screen up in here? All right, so these lines represent the best paths. So these little moving green dots indicate that, you know, if a penguin is on this cell, that's the direction it wants to travel to get there fastest. More or less. That's the direction it will go. They know all and see all. Now, the green paths, I think the way that works, it's like based on the possible spawn points, green paths are paths that a penguin could take. So you see like down here, there's like a dead end. I can kind of further that in a little bit. So up here, north of our castle, there's this big dead end. But there's still technically paths from those points. It's just the penguins shouldn't ever get there, but they could get there if like I walled one off. An igloo island as a set spawn point for the penguins. We are still considering spawn rules. How do penguins spawn? Do they just come from off screen, or do they have set points where they come in from? So one of the big things that was a problem was last week was the issue of how do I determine if it's possible to get to the castle. And the first thing we thought of that worked pretty well was that, oh, if I block a tile that is one away from the castle, and it's the only tile that's one away from the castle, then that should not be allowed. And that's true. If I'm blocking the only one, then there's no way to get into the castle from the outside. But it's not strict enough. Because in this case, I shouldn't block this one, the one that the hat is on. I shouldn't block this one, even though there are other ones. So if it's the only one, then yes, blocking it is bad. But there are other cases that are bad too. So basically, the way I got around that is I recalculate the paths every time you're about to create a wall, and then I use that to determine, is there a way to path to the castle? If not, you kick it out. You can't do it. Like right now, I can't create a wall here. Penguins can't travel diagonally, so I could create a wall here, and that's fine. But can't create one here. That's the rule. Diagonal was also a little bit of an issue because I found that penguins would be willing to go a long way around because diagonal is slower than straight. Straight paths are faster by a factor of 1.4-ish. So number of tiles away was not good enough for pathfinding because the penguins might go diagonally the wrong way and then back on a technically longer path because it's the same number of tiles. So I have to keep track of two different dimensions, really. I'm keeping track of number of tiles away, and also keeping track of actual distance away, so that the penguins can better calculate the best route. I don't remember what I'm using number of tiles away for, except for I'm using that for this little visualization. That's all I can think of right there. So yeah. So in short, right now what we have is we have actual pathfinding for penguins. Is this Minesweeper? Yes. And it's penguins. So I think the green dots are really helping visualize the path. So I'm not going to completely remove them now that we've got this working. I think I'm just going to comment it out because this might be useful for a player at some point to help a player visualize the paths that penguins will take, you know, in between rounds or something. I don't know. We'll work on it. So tonight, I think tonight we're going to work on actually managing resource gathering, perhaps, so that we can get an actual game loop going. Oh, see, I can move. Oh, okay, that's one thing, is that for the hat, diagonal movement is technically faster, because it takes the same amount of time to travel regardless if it's diagonal or orthogonal. I'm not too worried about that right now. We'll deal with that if it becomes a game issue. For now, the first thing I want to work on is these ice tiles that we're building on. They don't actually exist. There's nothing in the code that says that here's a tile and here's not a tile that you can build on. Like I could technically build some snowmen out here in the bottom left corner because it doesn't care. So I need some way to indicate. Let's just add some walls out here in the ocean. I need some way to indicate that there are tiles there. And then we're going to need to manage the draw order. We want to draw the sort of the ground first, and then the walls, and then the sprites. The walls look fine in the ocean. They do, except they look more like the ground. They look like floating icebergs that you can stand on. So what we're gonna do is we're gonna add another new sprite, and this is going to be ground tile.js. We're gonna make sure to add it to our HTML so that it actually pulls in the new code. The class name is ground tile. You will pass it in an X and Y tile location, and from that it will just draw. Which one will it draw? That is tile 0. Boom. Now we need to actually create that. We're also let's go ahead and manage Z indexing, like draw order. Let's call it draw order. And we're gonna call this one 0 because we want to kind of be at the bottom layer. And we can work out from here and do the others. Oh, we don't need to put it in the constructor. We can just put it in the class itself. Hat is going to be kind of towards the top. We always want the hat to be above all the other things running around. So we're going to put that as a 100 is what I'm declaring as a roughly normal amount. Penguins. Penguins are what? Draw order for penguins. All right, so it gets tricky with diagonals. If a penguin is kind of traveling diagonally next to a wall, that's where draw order is a little bit hairy. Maybe we want them to be tied. $50, I guess. We're picking some pretty arbitrary numbers here. Snowdrift. That's pretty low. We'll put that as a 10. Snowman. Draw order. We'll show the penguins over snowmen, I think. We can always change it later. Snowballs. 150. We'll draw those on top of penguins. Wall 50. We're gonna tie that with penguins. All right, got it. Now we're gonna update our code. Let's get the navigation mesh out of here. Oh, that's much cleaner, isn't it? And now we're gonna make it draw these in order. So we're gonna sort our sprites by draw order. I don't remember if this is correct, if this is the correct order or not. Hat is on top of the snowman, that's good. Hat is on top of the penguins, that's good. Actually, is that... All right, I'm gonna move the hat to the first thing that we create and see if it still happens. No, it does not. Okay, so we're not actually sorting these correctly. Why not? Hat is first. Oh, because it's first. We want it to actually draw last. It's still first. Dang it. Why? What's wrong with my sorter? I'm just confused Mario Maker 2 about how to lay stuff over the Z-axis simply with boo rings. I don't really use a lot of boo rings. I find them too boring. Oh, Germ Dove. On it. Incredible. Maybe it's this undefined one. Maybe I need to have a base draw order for everything, and maybe then it will correctly draw things in order. Oh, that might have done it. Yes, things are in order. Excellent. Yeah, we had some Z fighting. But now the hat is on top of all, which is what we want. But there is something a little bit screwy about that, which is how penguins are going to interact diagonally. Yeah. So, what I want to do is sort by draw order, unless the draw orders are equal. If draw orders are equal, then I instead want to I want to sort by Y location. Let's see if I can get this to work adequately. It worked right off the bat. All right, sounds good, Germdove. Yeah, so right here, when these penguins kind of work through this little gap, I need to remove the snowman. There we go. Got rid of the snowman. So now we should be able to see properly that, yes. All right, it's kind of hard to tell what's happening there, but this penguin right here coming in from the top, he's being drawn on top of the back wall, but behind the front wall. That's exactly how we want that to work. All right, so that's done. I'm gonna leave a comment here. Draw sprites by layer back to front for same layer. Easy. Do, do, do. All right, now we're gonna draw, or we're gonna start creating our ground tiles. So I need to get rid of this draw cells functionality, which is falsely drawing a bunch of fake items that don't exist. There we go. This is what the game is actually looking like. Oh, wow. I guess we need to clear canvas after all. So we're gonna do a clear canvas, but we're not gonna draw these fake tiles that don't exist. There we go. So now we're actually gonna create some tiles that do exist. Let's see here. Cell, column count, and row column count. All right, so what we need to do is we need to actually create those. We're going to initialize our map. Let's see here. Let I equal cell row count. No. I equals 0. What was I doing? I less than cell row count. I plus plus. And for let j equals 0 to cell column count j plus plus. So this is just going to loop through all possible combinations of the numbers 0 to 13 and or 0 to 12 and 0 to 12. And then I'm basically going to kind of steal this exact same code. Right here. X index, Y index. Sprites dot push a new, what do we call it? Ground tile at X index, Y index. All right, so let's see if that worked first of all. No, column is not defined. Of course it's not. Update these variables to match. All right, there we go. We're back. Now we have actual tiles that are being drawn at the back of everything. This is good. And also this means that when we are creating our setup here, our ground, we could randomize it slightly, as you can see here. So it can be a slightly randomized setup every time. We're probably not going to do random terrain. We're going to do some kind of predefined setups, at least initially. Oh, the castle. Our South Pole does not have a draw order defined. Let's just give it a pretty low one. There we go. Yay. All right. So now we have actual ground. The hat. When the hat is looking to see if you can draw something, or if you can create an element, such as a wall or a snowman, it doesn't check to see if you're on ground yet. So let's see here. Ooh. I need to have some way of defining that you can't build at a location. I need sprites to kind of have some kind of flag. So we're gonna say that you can't build if there is a penguin. We're gonna call this property blocks build, which by default is gonna be false. So we're gonna put the default value in our main sprite class, just so everything defines it. Which ultimately, we don't have to do that. If we leave it blank and we say if blocks build and it's just not define at all, it'll interpret that as false. But it's better to kind of be explicit on exactly what we're doing in our classes. Snowdrift. No building on snowdrift. No building on a snowman. No building on a snow wall. And no building on the South Pole. All right, so now back to our hat code. We're now going to say, is there a sprite that blocks? So we're filtering to, used to I just say look for any sprites that aren't a hat. But now we're looking for blocks build. And we're going to call this blocking sprite at location. Let's say is blocking sprite at location. And we're also going to say, we're also going to create a variable to indicate is ground at location. Which instance of ground tile, which is basically the same code. So we're gonna say you can't. You can only build if there's not a blocking sprite, and there is ground at the location. That's what we're looking for right there. So let's see if that works. I'm gonna try and build. Can't build a snowman on the water. Can I build a snowman here? Yes. Can I build a wall on the snowman? No. Can I build it on here? No. Perfect. That's effectively all we need right there, isn't it? Don't like the scroll bar, but it's not really an issue right now. It's just a little annoying when I'm using the arrow keys. I just need to not use the arrow keys. How about that? All right, cool. That's great. It's a great start right there. Already we've made progress tonight. Next, we need to define our currency. Ooh. Should we zoom out just a little bit further? No, I'm not sure. Something that I need to work on soon is some class that encapsulates a single level, like a level definition, a scenario class, something that would define what is the terrain layout for this mission, what waves of penguins are we gonna have, and then eventually there might be like what buildings are available, because we might do like a slow introduction, or maybe even a tutorial set of missions that you can optionally choose to do that will start you out with like, okay, in this mission you can only build snowmen and the walls are already there. In this mission, we're going to introduce you to the concept of building your own walls to send the penguins around. That kind of thing. So we want all of those different rules to be in some class that we can later start defining, and we can build these scenarios easily. And maybe allow for custom scenarios of some sort. You know, have a level editor? I guess that's I'm getting a little bit ahead of myself there. It's not unreasonable, because I've done level editors in games before. It's not that bad. In fact, if you do it early enough, then it makes it easier to build your scenarios, because you're using these nice tools, you know, instead of having to build it by typing individual rules in the code and say, all right, scenario 1 dot can use X equals true. Scenario 1 dot can use Y equals false. Instead of doing that, we get these, you know, a nice, neat little set of buttons, and we can just click them and just churn through making a bunch of scenarios quickly. That's what I've done on level editor style games before. It's like you build, you kind of, and we're already doing it in code here, you kind of by hand build your setup of what a scenario kind of looks like, and then after you've got that engine working, then you wrap the whole thing in a level editor that can produce the same results. And suddenly it becomes very easy to churn through things. All right. But you have to make it smart enough to be able to handle new things down the road. Like you can't imagine that you yourself are done making enemy types and building types. So you've got to make sure that your editor can support whatever building types are available. And you don't want to pull any trickery by saying like, these things are not available in the editor, because then you have to do them by hand. It's best just let people use it however they want. Nintendo, with your heavy stone block in Mario Maker 2. Your Toad clear condition. Oh, there's another thing I want to do. I'm not going to get sidetracked much, but I do know at some point I want to have some ability to make neighboring walls connect visually, and I don't want to have to draw every single combination myself. Because if I change the art later, I have to draw 30 tiles, a ridiculous number of combinations. Wouldn't it be nice if I could instead subdivide the tile into quarters and then have it stitch things automatically into all the 30-something combinations? I'd still have to draw 4 combinations. I think that's... Well, hang on. That's not paint. Bring out paint. No? Is it MS Paint? There we go. Okay, hang on. Let me think about that. Tangent. Super tangent. Okay, imagine we're just doing I don't know, ground tiles. Everybody's favorite. Just a grassy rock, and that's our one tile. All right. So imagine that's our one tile that fits to our grid, which is smaller than that. There we go. That's our grid. Classic grid. Classic uneven grid. Okay, so imagine that's our ground tile. But we have another ground tile right here. Well, then we want these two to connect. And so you'd have to... What you end up having to do is it's all right. So now I got to draw the top that looks like that, but it kind of keeps going at the bottom. And then I gotta draw a different one that, doesn't have a top and it connects like that to have a single piece. Oh gosh. Well, how many different combinations are there, right? Effectively, you have to account for, is there a neighbor or is there not a neighbor at all four neighboring locations. So 2, 4, 8, that's 16 combinations right there. And it gets worse if you're going to deal with diagonals, which that's up in the air if you want to deal with diagonals. But consider the possibility of a 2x2 block, because that's going to be one of your most common ones. If you're only looking at your 4 neighbors, then technically this block doesn't know about this one diagonally down here. And this should be equivalent to... hold on. Oh wait, and also this doesn't need to be here. If you have this set up here, right? See, this setup knows there's a neighbor to the right and a neighbor below, okay? It doesn't care about the diagonal. Well, guess what? This one has a neighbor to the right and a neighbor below. So if it doesn't care about the diagonal, how does it know? And then you wind up with a gap in the middle if you're doing these kind of tiles. I think that's okay for our use case here, where we're dealing with these snowy ice block walls. Because one, from a gameplay perspective, you shouldn't be making these thick walls, so we don't have to make it pretty. If you do make one, you should kind of look at that and be like, ugh, oh, right, I don't need to. But if we do want to kind of fill in the gaps, then we're now having to look at 8 neighbors instead of 4 neighbors. And what does that mean? That means that we're now dealing with 2, 4, 8, 16, 32, 64, 128, 256 different possible combinations of tiles. What? And we don't want to do that. So, my idea is if we do want to handle this kind of thing, then what we do is we subdivide our tiles. Only for the art. The actual in-game tiles are not subdivided. It's the same size. But we subdivide our tiles like so. Ad blocker extension for Twitch. Ooh. Yeah, uBlock used to work fine back in the day. So we subdivide our tiles like so. And now, oops. And now, we're dealing with a case where we never have to look at, well, there's different weird cases we have to look at now. But overall, I think we reduced the number of cases. But now we have to look at, okay, I need the top left of a left edge, top edge. It gets a little hairy. But this kind of setup could reduce the total amount of art if we program something like this. The question is, are we going to redo the art enough times to make that worth it? Probably not. But gosh, wouldn't it be cool if we built something that could do that? Where you draw a handful of actual main tiles and it subdivides that and kind of interprets how to do different combinations to give you every single possible combination you could ever need. So that's what I want to maybe think about doing at some point. For now, we're not going to worry about these being joined. The only other thing I can think of that we might want to join is the ground tiles to give them more, like, better defined edges and maybe a little bit of icy depth, against the water. Maybe, we'll think about it. Penguins. Let's talk about the penguin art. Penguin art. We want to have an art tile that indicates the penguin is underwater or swimming in general. Gosh, I don't know why my Photoshop is running so slowly. It's been like this for a bit. Okay, so when a penguin is underwater, and we have to be careful about which colors we use because we're trying to limit our color usage. Penguin underwater. Well, you know what? Let's create a background tile just for, there we go, just like that. And now let's draw on top of that. We're gonna draw our art, our lovely, ripply, kind of indicate that there is a penguin under the surface. Oh yeah, that's pretty good right there. Maybe a little bit of that. Maybe right like that. Trying to give it like a little ripply water look. Trying to figure out where to leave gaps and where not to. That might be good enough. Dang it. Of course, there we go, that's fine. We'll just do it like that. All right, merge layers, save as PNG. And now what we'll do on our penguin tile, on the old penguinos, is we're going to look at current is on water. We're gonna do it like we're gonna do it is on ground. Which we're gonna steal that from our hat. Our hat code is on ground. If it is on the ground, then we're going to use tile 3. And if it's not, we're going to use this new ripple effect here, which is tile 9. 9. Let's see how that works. Let's see if the penguins come in swimming. Oh, here they come. Ooh, and you know what? Maybe penguins can't be hit while they're underwater. That definitely needs to be an animated ripple. Looking at this, like that absolutely has to be animated. Yeah, that's not gonna fly, is it? All right, well, let's animate it then. One, two. Oh yeah, we did 20. That's weird. All right, let's ripple it out a little bit. So what we're gonna do is I'm gonna invert the color here so I can keep track of where the previous tile locations were. We're gonna push everything kind of out by one tile a little bit, just like that, to show that it's kind of rippling out right here. We'll do like that. Erase these two. Do. Just like that, like that. Did I do? No, wait, I'm not done yet. Ah, right, gotta do the middle. A little like that. Perfect. That's probably good. Do we have a... Do our sprites maintain their age? Do I maintain a frame number on a sprite? I currently don't. Let's just call it age for now. And whenever we're running our main code and we're running the update loop, we're gonna call sprite.age++. That'll just let us kind of keep track of where we currently are on that. And now we're gonna use that on the penguin. We're gonna say that we're gonna break this out a little bit. If it's on the ground, tile equals 3. Otherwise, we're gonna use this dot age. We're gonna do 30 frames each. So I'm gonna do mod 60. And we're gonna look for, is that less than 30? Yeah, let's do, why not? 9 or 10. Let's see if that looks okay at 30. Yeah, it looks all right. I'm good with that. I don't know if we should prevent penguins from being targeted while they're underwater. We might do something like that. Maybe this is a different type of penguin. You know? Yeah, it could be. We could do something like that. So we could do like draw the top half of a penguin while it's in the water, or something. I don't know. We'll figure it out. Let's see. Next. Oh yeah, they can even go underwater in the middle like this. Ooh, that's tricky. Like coming onto the land, it works fine. Coming from the land doesn't work because we're looking at the tile that they're currently standing on. Okay, this is actually a little bit tricky then. I want to look at the tile that they're standing on or the tile they're coming from. How do I get that? But for the sake of determining if they're on the ground, I want to know if they're moving onto a ground or if they're moving off of ground. I guess I need like an old tile X. An old tile Y. Yeah, I think so. And so that I'm not super crazy about this, but it will work. So we're looking for, is there a ground tile? At the tile you're heading to, or the tile you're coming from. Whoops, I see what I just did wrong there. Okay. Let's see if that looks better. Let me generate one that has water in the middle. There we go. That one right there will be perfect. So actually, the penguin might not even look like he's not going to make it, is he? Get the snowman out of here. Nope. He did as usual. He did as usual. Okay, well, that's not great. Wait, why though? Why though? Are we not keeping track of tile X and Y? -1, -9, -8, 0. That seems accurate. Oh, wait, no. We've got a capitalization error. There it is. Okay. That'll do it. All right, try again. Show me some better penguins. Let's see some good penguins here. Oh, and get rid of the snowmen. All right, let's see. Yes, okay. That's fine. So the penguin's just gonna kind of slide across the water there. It's not great. I get it, but it's not great. Because what we're going for is all right. Let's bring the snowman back. What we're going for is granted, this is all just visuals. This is just visual fluff at this point. I really need to focus on logic tonight, at least. But I can't help myself. Must do more fancy fluff. All right, no, we're gonna go back to logic now. We're gonna build our resource gathering next. So, again, the game loop is going to be it's tower defense, but in addition to having to run around, build your units, you're going to actually need to collect resources mid-round. And really, your only resource you can't get more of is time. So you're basically trying to use your time as wisely as possible in like, okay, I need to build my unit here, and I gotta go find a big pile of snow and collect that for a little bit, and then I'm just gonna idle there for a bit while I'm trying to plan out my next move. Okay, I'm gonna go over here, I'm gonna build a wall and a snowman and go back here. All right, grab resources, that kind of thing. In most tower defenses, you get resources based on the number of units destroyed. In some others, you kind of manage, just like life, apparently. Exactly, Shiner gets it. In this, it's mostly going to be you're trying to manage where can you best be spending your time. Because I think we might look into some ability to move units around, kind of possess the snowman, Frosty the Snowman style, and like drag them around slowly. Because I think that could actually be one of the most interesting pieces, is if you have to like very slowly move units around and they can't attack while moving. To manage like, oh, I've got units coming from the left, but oh, now I've got them coming from the right. I think it's going to be cheaper to kind of drag my units around over here. Kind of almost a very clunky RTS where you have to individually control every unit. Like you can't just click on them in bulk and say, everybody move over here. No, you have to one by one walk them over. That could be interesting. There's something to that maybe. Okay, let's deal with resource gathering. We want what do we want? Do we want to do our own font? I've not really done that, but that could be handy. Maybe a little bit pointless, honestly, considering that there's built-in functions for that. Yeah, let's not. Okay, will currency carry over between scenarios? Probably not, but maybe some kind of ranking based on amount of currency left. So initially, let's handle our total money as just a global variable. We might wrap it into some kind of object at some point that contains other game state information, but we just want to kind of get something going for now, right? So we're just going to have money. It is there. And we're going to draw our current money value. And let's start us off with 250 money. I don't know what an appropriate amount of money would be. Okay. Oh, we definitely don't need this anymore. That's gone. We're just gonna collapse that. After drawing everything else, we're going to do some kind of draw UI or draw HUD. Boom, HUD. Let's see. We'll just throw it on the top left for now. Hey, Snarky. Okay. Here is where always. All right, colors. We're having another game dev night. Grab this color right here. Boom, easy peasy. And with that color, we need to set a lot of things. Text align. I think left is the default. Let's leave it, but let's explicitly define it because we might be changing it later. Font. Yeah, it's temporary. So right now, the ripple, it's making me really want to have it so that the penguins can't be targeted while underwater. We'll see. Right now, the ripple is just kind of it's just a drawing thing. There's no actual functionality to it. It's just if the penguin is currently moving to or from a ground tile, then they draw a penguin. Otherwise, it draws a ripple. Which means that if it's a single tile of water, they never enter their ripple state, and they just kind of slide across the single tile, which it's okay, but I want to do it a little bit better later at some point. Font equals. Then you have to do like 16 point Courier, and that might be all you need. And then we do fill text. You give it the text, which is going to be money. And then the X and Y location, which is going to be, for now, 1030. There it is. Boom. Money. Thinking on that. Something that really bugs me is the way I'm, like, adding the canvas width and height half to, like, shift everything down. That's really bad. Don't want to do that, but it's okay for now. Okay, so now we've got our money. It's gonna update every frame. Hat code. We need to deduct money from our buildables. How many different things can we build? Like we never really dipped into that very much. I could just hard code this for now, but at some point we're gonna have to maintain like a list of buildings that can be built, individual costs, names, tooltips for like what they're good for. Yeah. So maybe that's fine for now, is we just check to see if you have enough money and then deduct it, and that's it. So yeah, I think that's what we're gonna do for now. If money is greater than, let's see, let's just do this like this. Cost of a snowman is 100. Sure. If money is if money is greater than or equal to cost, then money minus equals cost, and create a snowman. And then similarly for walls, except walls actually have a little bit extra that happens because we have to redo the navigation mesh. And we're gonna say cost of a wall is We're gonna make the walls a little bit cheaper. We're gonna say 25. I want mazing to be a pretty fun part of the game. I always enjoyed that. All right, so let's see if that works. I'm gonna draw some walls. Yep, it's deducting money. I'm gonna draw a snowman. Deducts money. Draw another snowman. Can't. Out of money. Draw a wall, a wall, a wall. Can't draw any more walls. Can't draw any more snowmen. All right. Wow, that was easy. Because we went really lazy on it. Right now we don't really have a great set like interface at all. Right now I'm just saying you hit number 1 to make a snowman, number 2 to spawn a wall, and that's it. In fact, I need to include that. There we go. And we'll add, eventually we'll add little like floaty numbers of like, cha-ching, oh, you lost 50 bucks for that. Oh, you lost 25 for that. And also it's not really money, it's snow. Oh, we gotta think of a pun currency, don't we? Because we had, for Moon Rover, we had Mooney. Mooney was the currency in Moon Rover. Let's see here. All right. Cold hard cash. That's the first thing that comes to mind, but that's way too much of a mouthful, despite the very clever pun. Okay, let's see. Slush fund. It's your. I'm just got a million of them apparently. Let's see. Ice, snow, slush, sleet. South Pole, other terms that are somehow related. This is how you make puns happen. Lots of terms. Igloo, snowman, frost, snowflake, Arctic coins. Okay. I could see Arctic coins working. You know, you reuse the sea. Although it's the Antarctic. Let's see here. It is snow. That's something of note, is that it is actually just snow that you're going to use to build more snowmen. Snow. No. Oh, no. Dough. Snow dough. No, I don't like that. We'll think of something. So just keep that in mind. You know, let that percolate. Oh man. Although I do at some point want to use the term slush fund somehow, even if it's just in flavor text. I was able to use satellite location in Moon Rover, even though it was just in flavor text. I'm good with that. That's all I needed. Okay, but you have money that you're gonna gain from snow. Now, here's the next thing is gaining more snow is based on your current location, I think, and only based on your location. So let's see here. So we have these snowbanks, which you withdraw from. Haha. And I think it's just going to be based on if you're on a regular snow tile, a regular ground tile, then you'll be getting snow every X seconds, but a very tiny amount. And if you're on a snowbank, you'll actually get a larger amount, or maybe more frequently be getting money. And this kind of creates this sort of like, they're going to be in out-of-the-way locations. So the idea is you have to, oh, you know what? I should add an outline to the hat, a light blue one, so it actually stands out against the water. Because I do want you to be able to go over the water. There we go. Perfect. Oh, look, I can actually see myself over the water now. That's all I needed. So the snowbanks, I want to be in kind of inconvenient locations, so it takes you a while to get over there to grab the snow and then come back to build things and move your units around. But I don't want you to get it, like, so fast that just, like, you idle while your things are going and you just get ridiculously rich. Maybe you only get money when you're on the snowbank. I don't even know. All right, so I still don't really have a great handle on how many snowmen are going to be appropriate, how many walls are going to be necessary, all that stuff. How frequently the penguins are going to show up, how much time between waves, because I kind of want the time between waves to also be still you're on the clock. Hey, Hudson. So, like, I don't know. How often should you be able to add more units? And I know a lot of tower defense games will kind of really ramp up the prices of things for, like, the high-end stuff. You know, like, oh, you've got your level 1 snowman is 100, but to upgrade him to level 2 costs like 500, and then to get him to level 3 costs 3,000 or something. Like, it really ramps up fast. I don't want it to be unreasonable like that, because I don't think that the amount of money per second you gain is going to ramp up during a round. Maybe that means more strategy, maybe it means less strategy, I don't know yet. So let's see here. How often should you be able to earn enough money to build another snowman? Should you be able to build another snowbank? Do snowbanks run out? Ooh, that would be interesting. Would it be interesting? RTS games like, I'm thinking of like StarCraft, Warcraft, they had resources on the map that you had to gather, but they actually ran out over time. Well, the snowbanks change locations over time. That could also be a thing. It'd be a little bit tricky because we want to make sure that, like, the map is well defined, it's not randomized, which means that you don't want to build in a location and then your building gets overwritten by a snowbank that was supposed to spawn there later in the map. I think they're going to be in set locations. I don't think they're going to change. Ponies. I think I don't know, what are you supposed to do during a round, you know? It's like in so many tower defense games you just kind of let things go. You know what? Maybe you can exhaust a snowbank. Like, it has a set amount of money in it, and once it's out, it's out. I think that would work. Ooh, that one was close. That one almost got to the tower. Not that anything happens right now. Yeah, let's say that a snowbank runs out. Snowdrift is what we called it. I do kind of want to change the actual name of this in the code now that snowbank is a thing, because it works very well. I think originally snowbank was going to be the term we used for your current money, but I'm now firmly in the camp of no, the snowbank is where you withdraw. So let's change that internally to make sure that that's something we can keep up with. All right. So if you are situated on the snowbank, then you will begin to gain money that you're kind of withdrawing from the snowbank. Eventually, the snowbank is gone. Which we need some way of representing that. I don't know if we do like a meter or just a visual animation. Isocoins. The right thing will come to us at some point. Slush fund. I cracked myself up with slush fund and cold hard cash, but none of those really work like Mooney did in Moon Rover. We're gonna give it some time. Let it marinate in our brains. All right. Cold cash. Nice coins. You get a nice coin. But it's not even supposed to be coins is part of it. Because it is literally snow. Your currency is you're literally gathering snow and then building snowmen with it. There's no exchanging of funds. It's literally the resource that you're gathering is the thing you're building out of. Nicey wicey spicy coins. Perfectly. Nice. Now we're talking. Okay, so we want to find there should only be at most a single snowbank. So we're gonna do find snowbank such that it is at the user's location. Buttons, like a button nose. All right, so we're gonna find the snowbank. If there is a snowbank that is on your location, then we're gonna do things with it. Snowbanks are going to have an amount of value. We're gonna call it money. We're gonna say that each snowbank by default is going to hold 500, maybe. Enough for 5 snowmen. Enough for 20 walls. And then each map can have like 3 or 4 on average. That seems reasonable. And we'll gather it slow enough that you can't just sit there and grab it all in the first round. That you're gonna have to leave and go do other things. If snowbank and snowbank dot money is greater than 0. Maybe a snowbank, when it empties out, it doesn't just get deleted. It kind of just gets like hollowed out. Like cold. Perfect. Let's see. Here's where we need to grab money from snowbank. LED lights broke today. They're like $5 at a Target clearance section though. Oh, well, there you go. How quickly can you get this? I don't want to go into decimals, so let's start with snowbank dot money minus equals 1, and snowbank, and then just your money plus equals 1. Grab rate equals 1. Well, I gotta be careful here. I want the idea that maybe over time you can start to increase the speed that you can grab snow. Like you can purchase some kind of upgrade that starts very small but works its way up. In fact, we may scale all money by a factor of like 100 under the hood, or maybe 1,000 even, just so we don't have to deal with decimals. Floating points can get a little bit iffy in JavaScript sometimes. What do I mean by that? What's a good example? Is it 0.1? Here we go. So here's your example of how floating point numbers get weird in JavaScript. Direct your attention right here. 0.1 plus 0.1. What is that going to be? 0.2. Reasonable, right? 0.2 plus 0.1. What's that going to be? Did you say 0.3? Close. It's 0.300000000000004. You were off by a tiny bit. This is an issue in computers known as floating point errors. What it comes down to is computers do not store numbers the way you think they store numbers. Now, as a normal human person, which I hope you are, you might think to yourself that numbers are stored the way we think about numbers, which is, if you want to store the number, let's choose a better one. If you want to store the number 13, you're thinking, okay, we're storing a 1 and a 3. No. Deep down, as I'm sure you all know, but you don't really think about what it means, computers store things in zeros and ones. Ultimately, everything is electricity. Zeros and ones is actually a bit of a misnomer. Don't think of it as zeros and ones. Think of it as light switches in your house. Okay, you've got your light switch panel, and you got a switch that controls the overhead light and the hall light and the fan and this other one that you don't even know what it does. And each one can be on or off. On or off. There's 2 states. Computers store things as electricity, sort of. And this isn't the case for all storage mediums, but it's kind of stored in the sense of there is, because some of them use there's magnets, RAM is electric. Okay, well, all right. Everything I'm going to say, there's a lot of, this is an oversimplification. But it's basically like a bunch of switches that the computer can turn on and off and then look later to see if they're on or off. But there's only 2 states. In some cases, that means there is electricity or there's not electricity in this one circuit. Or this circuit this portion of the drive is magnetized or not magnetized. So it's not really stored as zeros and ones as we think about zeros and ones. It's stored as some kind of thing that can be in one state or another state. All right, you with me so far? No? Get back with me, Hovercat, come on. So, we abstract that into zeros and ones, but technically under the hood, there's no zeros or ones. There's just these states of some physical phenomenon. Yes, a series of true or false switches. I like my light switch idea better. So it's a light switch, but for our convenience, we're going to think of it as zeros and ones, switches that are off or on. To store the number 13, as a series of switches, we're not going to flip 13 switches and say, boom, we stored the number 13, because that's very inefficient. Especially if you wanted to store some big number like 2 million, you're going to run out of switches really fast. Magic Shiner, it's pure magic. So this is where binary comes in. Since we can only store in zeros and ones, how does this number work? How is this number 13? We have a 1 and a 3. How does a 1 and a 3 make 13? 1 and 3 is 4. Think back to elementary school. This is not a 1. This is secretly a 10, because it is in the tens place. And this is still a 3. Now 10 plus 3, that does make 13. 3 times 1, 10. 1 times 10. Actually, let's bring that back. Let's take the number 135. All right. Thank you, Green. You're jumping the gun. This is the 100s place. This is the tens place, and this is the ones place. So it's 1 times 100, which is 100. 3 times 10, which is 30, and 5 times 1, which is 5. That's how the numbers 1, 3, and 5 form 135, because we've kind of agreed that when you put numbers right next to each other, that's our way of saying add the rightmost number to 10 times the next number to 100 times the next number, and so on. And then, then it's 1,000 and 10,000s place and 100,000s place and the millions place. That's the decimal system. Dec as in 10. Decimal, decimate, December. There's probably some other words that, Latin. It's cool. Binary. There's only 2 state, or everything's in 2s. So the first number is the ones place. Let's see here. So a binary number, you have a ones place, a twos place, a fours place, and an eights place. It's the same pattern, but instead of multiplying the place by 10 every time, it multiplies by 2 every time. Okay? So we do the exact same thing we did with our decimal number. 1 times 8, that's 8, plus 1 times 4, that's 4, plus 0 times 2, that's 0, plus 1 times 1, that's 1. Sum those up, and what do you get? You get a decimal 13. Wow. Incredible. Okay? You with me so far, guys? Because it's about to get weird. How in the world, knowing this, how in the world do we now handle decimal numbers? Integers are one thing. They're not too bad, okay? Integers are all right. But decimals is where things get weird, because they can keep going. A decimal number can just keep going any number of places off to infinity. Now, integers, we actually have a maximum value. I wonder if is that in JavaScript? Can I like number.max? I can. Number.max, the maximum value JavaScript is cool with is 1 followed by 308 zeros. How do you do powers for decimals? That's more of a math question. There is a way, but it gets tricky. Unless you're talking about, if you're talking about like 1.5 to the 2 power, that's easy because that's 1.5 times 1.5. Now, if you're talking about 5 to the 1.3 power, that does get tricky. There are formulas for it, but they're not super useful. Anything you're doing that requires something like that, you're probably going to make a computer do it. Oh, okay, you're talking binary. So, thank you for the follow. welcome to the binary lesson. All right, so here's our problem. Here's our big problem. How do we handle decimals? You know, integers, we have a set number of integers, and once it goes past a certain number, we say, that number's too big, don't worry about it. We'll never need to use it. And you have to do some special case handling to deal with that. But decimals are tricky because they don't keep getting bigger. They keep getting more precise. So here's the idea. Here's how decimals work. This is, again, a simplification, but it works. We define a set number of, let's say, spaces for... All right, hang on. Let me think about this. Scientific notation. You guys know scientific notation, right? 5.03 times 10 to the 5th power. Now let's make it 6th power, so we don't get repeats on our integers here. Really useful, isn't it? Okay, so scientific notation basically boils down to put a lot of focus on this first number here, and then some number after the decimal place, but there's always one number before the decimal place, times 10 to the something power, okay? That's the basics of scientific notation, is it's, you know, something dot something times 10 to the something power, all right? This is kind of how we store floating point numbers, okay? We define a certain number of spaces to be the first part of the number and a certain number of spaces to be the last part of the number. And so, you know, this becomes, if this would effectively be something like this. Dang it, I said the word. You got me. Okay, so here's our silly example that has 10 slots where we can store, again, nice, where we can store this number. All right? I'll let that play out. All right. And we kind of do the same thing with a binary number, where it's 1.01011 times... I think it might still be 10. I'm not 100% sure on how they do that. No, it would have to be, no, it's 2. It's 2. Times 2 to the 1001101 power. All right, something like that. Now this is a decimal 2 right here, just so you know. You know, I'm mixing bases, but don't worry about it. And so we just kind of plunk those into a single container, and that is our floating point. But that means we have limited space for the exponent and the mantissa. This is called, in scientific notation, this is called the mantissa, just so you guys know. That's a fun little fact for you, fun terminology. We have limited amount of space to store those, so we can't get super precise. Now, if the number is something like, let's see. If it's 0.5, that fits perfectly in binary. In binary, that is effectively 0.1. That's the binary representation of 1/2, I think. 0.25 is 0.01. Because it's working the same way as like a tens place and a hundreds place does in decimal. You've got a half place and a quarter place and an eighth place. So, if you have a half place and a quarter place and an eighth place and a 16th place and a 32nd place, well, you can represent so many numbers perfectly, but you can't actually represent 0.1 perfectly. Because by definition, with binary decimals, you can only store things that are based off some power of 2. Once you get off of powers of 2 and there's any other prime factorization in there, you're never going to get it exact. You're going to get it really close, but you're never going to get it exact. Oh, you're just in time for the grand finale here of why I finally explain why you can't have 0.3. So 0.1, let's see, is there a way to do 123 dot string 2? Yes, okay, you can do binary. So 0.25, let's zoom way in on our console here. Well, that's a little too far. So a quarter in binary is 0.01. 0 in the ones place, 0 in the half place, and there's 1 in the quarter place, because it's equal to 1 quarter. So what happens when we try to represent some weird number like 0.1 in binary? This mess right here, this is as close as we can get to representing 0.1 if we need to represent it in binary. That's a bit of a mess. But it's close enough that when we convert it into decimal, that it rounds out very neatly to 0.01. Not perfectly, but close enough that you don't see the rounding errors. The problem is when you do 0.3 in binary. 0.1 plus 0.2 equals 0.300000004. It's a little bit too imprecise. We can't quite store these tiny errors. These tiny errors that you don't see individually, when we add them up, they barely show up at the end there. All that to say that when we're doing money, I don't want to ever add 0.01 money. I don't want you to be able to get money 1% faster with such and such buff, because we're going to wind up with those problems. What's pi in binary? Well, it is that 11.0010010000001111111. Super useful. Whew. So, but what rounding mistake does carry through? But what rounding mistake does carry through the decimals? What rounding? Oh, okay. So 0.1, when stored in the computer, is not stored as 0.1. It is stored as this massive string here, or this massive set of on and off switches here, which looks pretty close to that. But if you actually convert that back, that's not exactly 0.1. That's what is that? Half, quarter, eight. That's a 16th plus a 32nd plus 1 over 256 plus 1 over 512, etc. So it's not exactly 0.1. There's a slight error. It tries to get really close. How does it round up pi? Wait, why are we talking about pi? I mean, this is definitely not precise, obviously. But we kind of know that, oh, you can never write out the exact value of pi if you're using integer numbers or, a decimal system. If you're using the numbers 0 through 9, no matter how many places out you go, you can never get pi exactly. So it doesn't matter if it's decimal or binary. Pi is always going to be kind of represented with some kind of truncation. You're going to kind of leave off the end. Does it start to drift around the 8 decimal or farther. So you mean like if I took this this binary representation and I converted it exactly back to decimal, how many places off would it be? You know what? We actually can calculate that. We can calculate that. Consider this first decimal place is either going to be a 0 or a 1. Which means it's a gulf as big as 1/2. Which means if we left that off, then our number could be off by up to 1, I guess. Not quite up to 1. I saw. Oh, yeah, that was what it was. I saw that you figured it out. I didn't see what the answer was. We might be off by like a factor of 2 here, but this first one, if we cut off right here in the first one, we're off by as much of a factor of like 1. So each decimal place we add cuts that by 1/2. Okay. So we're looking at 48 decimal places. Math.pow, 2 to the 48. So let's see. If it was just 4, then we'd be off by as much as 1/16, which means our error could be somewhere around the second decimal place. But because we're dealing with 48, we're instead looking at it could, not necessarily, but it could drift off around the 15th decimal place. That massive number. This massive binary number representation of pi, if you convert it to decimal exactly as is, it should be accurate for about 15 places. And that makes sense because, let's see, 10 decimal characters carries the same information as about 10 binary carries about as much information as 3 decimal places. Because 10 binary digits, does the word digit still apply? I guess maybe 10 binary, let's say digits, carries enough information to convey the number 1024. Almost exactly 1000. Which you can get 1,000 different numbers in decimal using just three digits. So there's roughly your conversion. Is that 10 binary digits is about the same information as 3 decimal digits. It's not exact, but it's close enough if you need to eyeball it. So anyway, we were building a game, weren't we? How about that? Maybe we'll do a little bit more of that, huh? Delicious. Okay. We went on a very long tangent about decimal and binary because I wanted to say that I want to be able to store money more precisely than I display it, I think. Because at some point it might be nice to say, oh, you're gathering money 5% faster with such and such perk. But I don't want to give you 1.05 money because rounding errors will do some weird things. How to memorize decimal pi for a contest while I got around 32 decimals memorized and forgot since. I know 50 digits of pi.
You still know 50 digits of pi?
I bet I do. Should we figure out if I do?
I guess I have to participate, right?
Maybe. Okay. Hovercat's gonna check me on this. All right, here we go.
All right, I'm ready.
All right, you ready?
Yep. I'm ready.
Okay, here we go. 50 digits of pi. 2 point... Oh, wait.
Are you going to keep track of the note on your fingers, how many you're doing? Or do I need to do that part too?
Oh, I mean, are you just looking at pi?
I was just looking at pi, yes.
Okay, that should be good. You should be able to just follow along, right?
Okay, yeah.
Oh, until I get to
your
50.
actual number.
Oh, gotcha. That's a good point. All right. Oh, boy. It has been a while. All right. 3.14 15 9 2 6 5 3 5 8 9 7 9 3 2 3 9
Nope.
Ugh. 8 4 6 2 6 4 3 wait 4 3 3 8 3 2
Are we saying numbers?
7
2, 4, 7, 6,
9,
1, 19.
5 0 2 8 wait that can't 8 4 1 9 7 1 6 9 3 9 8
No.
oh 9 9
Yep.
okay 3 7 5 1 that's it.
0.
Oh man, I didn't know.
Yep.
There you go.
So, I'm interested.
Uh-huh.
The way that you got things wrong
Yeah.
leads me to suggest, leads me to think
Uh-huh.
that you have memorized it in a certain way
Yes.
because you were off by like one
Multiple
number.
times.
Yeah,
Yeah.
like 2 different times.
Mhm.
So, how did you remember?
I'll take this secret to the grave. No. I cheated.
Uh-huh.
Sort of. All right. When I was in, it probably would have been around. It would have been around 2005, 2006, leaning towards 2005. The era of Stumble Upon, the Firefox
I remember it.
add-on. Yeah,
I never really got into it.
it was like one of the early like aggregators of interesting things before your digs and Reddits out there. So one of the things I stumbled upon was a website of a guy who would make songs based on suggestions. It was Songs to Wear Pants To
Oh, I remember that.
was the name of it.
Yeah.
He made some very interesting things, like make a rap about the letter E, but don't ever use the letter E in any of the words you say. Like really weird kind of
yeah.
challenges. And one of them was like, there's this girl I like. She's got really nice hair and really beautiful eyes and really good body. Can you write a song about what she means to me? And then he writes this like, I don't even care about your personality. It's like, ah. Anyway, one of the songs was, can you make a song about pi where every word has a number of letters equal to the next digit in pi? So the first word in the song has 3 letters. The second word in the song has 1 letter.
Right.
And so on. So I'm like trying to count letters in the words, but it's weird words.
That's why you were one off, especially on like 8 and 9.
Yeah, it's weird words.
Bigger words.
Man, I shan't formulate an anthem where the words comprise mnemonics, dreaded mnemonics for pi. The numerals just baffle me always, even the dry anterior. Try to request something lower, 0, in numerary accuracy, aptitude, even I, pantaloon gallant, I cannot actualize the requested mnemonics, the leading 50 I... And that's how the song ends. And that is how I remember the first 50 digits of pi. Mnemonics. Stumble Upon was a fantastic thing back in the day. What were we doing? Money, currency.
Sorry.
We had to take a break to recite the first 50 digits of pi very slowly. Yes, money, pi. Well, it was one of the few places I found that was like just giving away songs, and I was like, oh, yes, I want music. I want to listen to music for free. Give me this music. You add ponies to the game yet? I don't know if the ponies would do well in this climate. This is the South Pole, after all. Eden? No, I have not, Hudson. Oh, got him. Ice ponies. Evil Santa. I mean, I guess that does stand to reason that if good Santa lives at the North Pole, that evil Santa must live at the South Pole. All right, so... what we're going to do is we're going to... how do we do this properly? Geographically inaccurate bears. Like, that could be what we call them. Like, that could be their official name. It's geographically inaccurate bears. It's like, I could just say money is scaled by a factor of 1,000. And then we draw it by dividing by 1,000 and all that stuff. Oh, Shiner, you had a question about two fixed and why that might be bad or not be bad. What was the question there? What were you doing? To fixed 2 and turn it back into a number. Oh, to like divide by 100. Rounding. Sounds better than to broken. It probably won't ever become an issue, but it could, you know? Performance is a slight concern. You know what? Actually, you're right. So 2 fixed does do rounding. So if I had 100.5, actually if I do 2 fixed 0, that does round right there. And it does round correctly as well. So the idea is every time that the money gets modified some way. Oh wait, I know why. I know why I want to do this stupid thing. Because 2 fixed. Because I do actually want to store more precision than I'm showing, because I want you to be gathering snowballs in smaller units than you can actually use. So I'm thinking like you gather snowballs per frame while you're on a snowbank, rather than saying, oh, you get a snowball every 5 frames or something. Instead of keeping up with that, you're instead going to be getting like a 1/5 of a snowball. No, that's stupid. No, I can't decide. Everything seems wrong. Everything seems like a bad idea. I'm in that stage where I just don't know how I want this to go down with the money gathering. All right, let's see what happens. Let's see how fast I get money here. Ooh, that's very fast. That's very fast. Count by flakes. Now we're talking. See, that's very fast on the money. It's going to be out of money soon. Oh, yep, it ran out of money. So I could make it only happen if the current frame is a multiple of something. You know? If this dot age mod 30 is 0. So that's saying every 30 frames or twice a second, grab money. Do. Yeah, see, that's much more reasonable. And this could be where I change the speed. Modulo operator is a, oh my gosh, MVP. Do. Okay, and grab rate. This is, I'm not even sure if this is going to be necessary, if we ever are going to need to change this at some point. Let money grab equals whichever one is smaller, the grab rate or the amount of money left in the snowbank. And then deduct that money from the snowbank, add that money to your account. Your slush fund. Haha. Get them if it's pressed and not held, so you can just mash to collect money. Oh gosh. That seems like the exact opposite of the kind of fun I want to have on a tower defense game. I do kind of want to speed this up a bit though. See, at this rate, this is 4 per second. This is 4 per second, which means it would take 25 seconds to have enough to build a snowman. It would take 6.25 seconds to have enough to build another wall. Maybe that's okay. Because maybe the idea is that during round 1, you know, you're going to have your initial money, you're going to lay out your initial snowmen and walls, and then you're just going to sit on the slush, kind of farming it for a while. Sit in the snowbank. Does that make sense? And then go build more. Does that work? Kind of, I don't know. We'll stick with it for now. If I did 6 per, Then it takes you 16 to get 100 money. It takes you 4 seconds to get enough for a wall. Yeah, that might be a little bit more reasonable. Also, I'm even considering that maybe walls should be even cheaper. Like 20. So you can build 5 walls, or you can build a single snowman. I really want to push the mazing stuff. I think the mazes are cool. I think that's a fun thing in tower defense. And I want you to have the ability to do that. Well, here's the real reason why it's not as much. And that really comes down to the fact that the penguins can move diagonally. Which means you have to fill in every corner. Like right like that, that's not good enough. So it does end up taking quite a bit. Hey Jad, welcome. Hope you're doing well. Okay. But this at least gives us our basic game logic of you actually have to collect and spend money. There's still no UI indicating prices or anything, but that's all right. A snowdrift that is used up. How do we represent that? How do we show that we got a snowdrift that's all empty? Do we just like flatten out the lines? So it just becomes like these just blue lines that have nothing else. It's a little bit sad looking, but I guess that's the point. Hey, Pixel. Sliding on in here. And actually, that's really easy to do in our snowbank code. We just say, if this dot money is less than or equal to 0, then this dot tiled is now, that is tile 12? Pixel, thank you. $10 going to Camp Horizon. In fact, let's go ahead and let's really speed up our let's see it actually change to empty. Whoop, it just completely deleted. Oh, whoops, it's not 12. It's 11. I can count. Everybody stoked for tomorrow? I'm excited. In just 12 hours. Wait, was there a 12 hours remain in Majora's Mask? I don't think. Oh, there was night of the final day. That's perfect. Oh, it's absolutely perfect. Give me that image. Let me just copy that image right off of the internet. And throw that right in here. Perfect. What's even going on in GDB? You know what? Let's take a look at the schedule. What is going on in GDB, guys? What is going on in Games Done Badly? Oh, I don't know. I never really use mobile. All right. Games Done Badly, 2021. Let's take a look at what we got here. These times are not actually accurate. These are Central Time. Hold on. Let me just change this over to, let's say, Eastern. It's gonna be the best for everybody. Boom. Look at that, automatically updates. Did you guys know that? Did you guys know that the website will handle different? Let's put it on. Boom. There's UTC right there for all our British friends. Bye bye. Pixel, these times are for you right here, assuming that you're in UTC. Assuming that you are in fact in UTC, then this is exactly when times are. Assuming it's 2 a.m. for you, you can look forward to a nice afternoon Germdove stream. All right.
Bonus ducks.
Perfect. I do like bonus ducks. Eastern time zone. 10 a.m. tomorrow. Our very own Germdove is doing Jurassic Park 2. He's doing some game, and he's going to get a world record in it. He won't tell us which game. He's giving out hints. UTC +1? I had no idea. Man. How weird is that? Teddy is going to be doing well, I don't know if he's still doing Super Metroid Zelda Randomizer, or if he's picking a more reasonable randomizer that might be possible to finish in 2 hours. We'll see. GameCube, we don't know what he's doing. He's keeping his a secret as well. Day had some things she threw out. I just left it blank on the website. She might be doing what was it? Endless Ocean, one of those scuba games. Which is weird in like every way possible. Yeah, that's all right. I'm really looking forward to Turtle doing Minecraft Skyblock. That's gonna be a hoot and a half, as James Bod would say. And then that night, after Turtle finished up his Minecraft Skyblock run, we're gonna do some multiplayer stuff. Probably Jackbox and similar things. Sunday morning, Duffy of Hula Cow Studios is going to be playing some old. I think he's settled on NES games. He was still a little bit on the fence, but some very poorly known games that I'm sure you're all going to really enjoy. If anybody doesn't know who Duffy is, what if Turtle messes up the cobblestone generator? I did mention that I'm looking forward to that happening and the run ending in the first minute. For anybody who's been keeping up with the 6-year Mario Maker, 5-year Mario Maker, who knows what it is, Duffy is the one that does the voiceovers for the trailers for those. Oh man, you guys. 7-year Mario Maker. Shiner on Sunday is finally breaking out the Philips CDI after I've been pestering him about it for probably over a year now. He is finally going to get around to showing off Wand of Gamelon on stream, among some other Philips CDI games, which are equally as hilariously bad. The Caesar's Palace game has a fantastic intro, just so you know. Tank, I think, was looking at doing some randomizer. No Hotel Mario. I don't think he has Hotel Mario.
You know what they say, all toasters toast toast.
Panda's doing some randomizer, maybe a Final Fantasy randomizer or something.
You know what they say, all toasters toast toast.
And then Sunday night, tune in at the normal stream time, for the Wheel of Dobbs, where contestants can win fabulous non-prizes. And after that, we'll do some more multiplayer games with the crew. All these people are involved. Maybe more. Oh, look at this fancy CSS transition. And that's it. All right, so that's the schedule. So get excited. I'm excited. We're gonna see a world record live tomorrow morning. Oh look, yay, our tile flattened out. It's all empty of snow. Bright and early. I kind of add some spaces in here to kind of make it more of a dotted line. That's fine. Okay. What else do we want to work on tonight here? There's still the possibility of having an actual, like, scenario object that we run. That's right. Took years of practice, but I finally pulled it off. You guys want to see something stupid that I learned today? All right. So, in HTML, there's an element that you never see used. Nobody ever uses this, but it is part of the official HTML spec. It's supported by web browsers. It is called the meter. This is a meter object. Now, what's an HTML object? I'm talking about things like a dropdown, a text header, a table, an image object. These are all elements in HTML. One such element is called the meter, and it is basically like a static bar that gets generated. You provide it with a minimum value, a maximum value, and a current value. And then it will show a meter filled up to some fraction. The cool part about it is that you can provide it a set of good values. Low, high, and optimum. So let's see here. It is between min and low. I don't know exactly how it determines. Technically, you could change it, yes. So here, I'll show you using this one right here. Let's see if I can mess around with this one. Value. Can I mess with this? Like I could change it to 60, or I could change it to 70, and see it like changes color when it gets to a certain threshold. Oh wow. Interesting, right? Well, you use CSS to control the appearance of things. Like in the case of the meter object, you can use CSS to control its width. For example, this one right here. Let's mess with this smaller one right here. I could control the width and say it's 500 pixels long, and it's 50 pixels tall. Well, now you can't even see it. There you go. So you can control the size of objects, but also to some degree you can control the color of objects. And I was looking into it. I was like, how do you change the color of a meter since it already has like it has 3 different default colors for low, optimum, and high, and also the background color. You know, how do you control all 3 of these different colors? And oh man, what I found is the stupidest thing. All right, hang on. Wait, hang on. Let me find this on the spec sheet, on the actual. Here we go. We're almost there. This is the place. Oh, here it is. All right. So apparently, the name of the property you have to change if you want to change the red color to something else. Here is the name of the property. WebKit meter even less good value. This is an official property but it's not in the CSS spec. This is a not fully supported feature, non-standard. It's a non-standard feature, but they named it the even less good value. You have optimum value, you have suboptimum value, and then you have even less good value. That is what they called it. This is actually pretty well supported. It's not supported in Firefox, apparently. So you can't override the color of a meter in Firefox using WebKit meter even less good value. But I don't know. I don't know who thought that was a good name for that. Optimal, suboptimal, even less good. That is what they went with. That is out there in the world, in code bases. Browsers have to support that. Anyway, that might be why meters aren't used very often. They're not super useful. They're basically just an image that I guess you can generate a little bit easier. Whatever. Okay, the point is, today we added the ability to gain resources and then to spend resources. Haha, now these... Why do they only come from the middle of the sides? They actually come from the top and the bottom of the sides, but their pathfinding kind of brings them towards the middle because they've elected that to be the quickest way to get closer to their goal. Consider, if you will, a penguin coming towards the South Pole. There's our South Pole. Our little penguin friend here. There he is, looking very dapper. All right, so our penguin here. He's trying to get to his target. Right there. And he is currently positioned right down here. All right? So he has this big grid of cells that he's working his way across to get to his goal. What a great grid, right? All right. So he's working his way across. He has multiple choices of which ways he can go. Now he could go like this, zoop, or he could go like this, zoop, or he could kind of do a little stair-steppy pattern, whatever. It's going to take him the same amount of time either way. But right now he just needs to pick his first step. So he can either go this way or this way. Technically, both will get him there at the same amount of time. But initially, this way gets him geographically closer than this way does. And that is why he chooses to go diagonal first in this instance, is because he's looking ahead exactly one move at a time. You know, there's all this pathfinding going on for the whole thing, but initially he's just trying to find the one step that will get him closest in one step. And that is always going to be, he's always going to make his diagonal moves first and then a straight shot. because his diagonal moves will kind of get him closer. Even though we know it doesn't matter, he doesn't really know that. That's it. That's the stream tonight, guys. I hope you learned a lot about binary, a little bit about pathfinding, something about HTML meters. I know we didn't get a lot of actual visible progress tonight. We added a money UI thing in the top. That's it. That's all we did. I'm thinking next time I want to actually define scenarios. We took away something visible. Wow. Incredible. It actually looks less, like there's less here. What are the penguin spawn points for random? I have considered that. Currently they are. Currently the penguins actually have random spawn points off screen. Like top to bottom, a little ways off screen. Every single location can spawn a penguin. I am leaning towards not doing random spawns and having our scenarios predefined. So it's like every level will be a list of things like at 0 seconds, begin spawning a wave of penguins at this location, make it last for 30 penguins, and then at 15 seconds, spawn a second wave of penguins starting over here that goes on for 40 penguins. And then at 20 seconds, spawn another wave of different type of penguin and spawn 10 of them over here. So we have these ways of defining penguin waves. And then we can use that to not only spawn the penguins, but maybe to also have some indication to the user, like, hey, upcoming wave coming, you know, in 5, 4, 3, 2, 1, here come the penguins, and then a bunch of penguins show up. Something like that. Classic. I used to have so much issue with that, with my old capture card. I had an external capture card, so it had the, it was like a full, like almost 2-second delay sometime, between what you guys saw and what I saw. Where you would see like my webcam reaction before you would see what happened in the game. And the way I got around that temporarily was just adding a delay to my webcam and to my audio, which was a mess. The new capture card is not latency free, but very, very close, especially by comparison. Like it's a fraction of a second now, which is good. I can't play off of it, but I can at least have my reactions be more appropriate. All right. Is anyone from GDB? No. Does not look like it. All right. Well, guys, we're going to call it there. We're going to end stream. Rover is in the code. Rover. Good job. All right. You might have. All right. Tomorrow, guys. 11 hours, 40 minutes away. See you at Germ Dove. Should we raid Germ Dove? We're not going to raid Germ Dove. Just to set everyone in his channel to be prepared. All right. Good night, Pixel. Good night, Snarky. Good night, John Boy. All right. Bye, guys.